Hi class, how are you today? You're a square. The learning target for today is to be able to simplify square roots with variables and divide by binomial square roots. For the scale, you're a 3 if you can simplify square roots with variables and divide by binomial square roots. You're a 2 if you can simplify square roots with variables or divide by binomial square roots, one or the other. You're a 1 if you can simplify square roots and rationalize the denominator. That's what we did in the last video. And 0, you cannot simplify square roots and rationalize the denominator. All right, let's get started. Okay, so we're simplifying square roots just like we did in the last video. However, now we've added variables. So the best thing that I suggest to do is, before you do anything else, split these up. So we've got square root of 28 and square root of x to the 5th. So now simplifying square root of 28, that is done the same as it was before. So what's a perfect square you can divide out of 28? 4. So we split this up into square root of 4 times the square root of 7, because 28 divided by 4 is 7. And so then the square root of 4 is 2 times the square root of 7. And then we look at the variables. So what we want to do here is to take out all the perfect squares. Well, there's a few different ways we can do this, but probably the easiest way to recognize right off the bat is just take out all of the perfect squares, all of the x squareds. So we've got square root of x squared, square root of x squared, and square root of x. What I did here was, in square root of x to the 5th, well, 5 is 2 plus 2 plus 1. So I took out x squared, so I took out 2. I took out x squared again, I took out another 2, and there's 1 left. So we have the square root of x squared is x. The square root of x squared is x, and the square root of x. So now we multiply all of this together. And so we look at what's in front first. We've got the 2, and we've got 2 x's. So x times x is x squared. And then underneath the square root, we've got 7 and we've got x. And this is our answer. So in this next one, we want to split it up again. So we've got the square root of 54 and the square root of c squared d cubed. Now you could split c squared d cubed up into each of their separate square roots, and that's perfectly fine to do. But for this example, I'm just going to keep them the same. But if you want to split it up again and have 3 separate ones, that's perfectly fine. So the square root of 54, what's a perfect square you can divide out of 54? That would be 9. And 54 divided by 9 is 6. Then we take out all the perfect squares out of the variables. So c squared is a perfect square. So we've got times the square root of c squared, and then we take out a d squared, and we're left with a d. So the square root of 9 is 3 times the square root of 6 times the square root of c squared is c times the square root of d squared is d times the square root of d. Put that all together, outside first, then inside. Outside the square root, we have 3cd. Inside the square root, we have 6d. So the answer is 3cd times the square root of 6d. That's the answer. And this last one is, again, just the same. We've got square root of 75, square root of qr to the 6th. What's a perfect square you can divide out of 75? That'll be 25 times the square root of 3, because 75 divided by 25 is 3. And then q has no perfect squares, take out of it, because there's no exponents, so it's just square root of q. And r to the 6th, well, that's 2 times 3, so we'll have 3 r squareds. So square root of r squared, square root of r squared, square root of r squared. So we've got square root of 25 is 5 times the square root of 3. Let's do the perfect squares first. Square root of r squared is r, square root of r squared is r, square root of r squared is r, times the square root of q. So we've got outside first, 5 times r times r times r, or r cubed, because we have 3 r's. And then inside, square root of 3q. And that's our answer. All right, and now we're going to be dividing. So again, just like we did in the last video, we want to rationalize the denominator. We can't have the square root in the denominator. However, it's different this time because we have binomials. That plus and that minus gets in the way, and it makes it much more difficult. We can't easily just multiply by the square root of 5 on the first one, for example. So we have to multiply by what's called the conjugate. So the conjugate on the top and bottom will be the denominator, except with a different sign for the square root. So the conjugate of 4 plus square root of 5 is 4 minus square root of 5. So we multiply the top and the bottom by 4 minus the square root of 5. And the reason we do this is from a difference of squares. And let's multiply the top one. It's just simple distributive property. 3 times 4 is 12. And 3 times negative square root of 5 is negative 3 square root of 5. Over, and this is where the difference of squares comes in. We could multiply this out, or if you know difference of squares, this will just come out to 16 minus 5. The way that works, and this is always the case, is that we're taking 4 plus the square root of 5 and 4 minus the square root of 5, and we have to multiply it out. We have to multiply everything on the left by everything on the right. So we have 4 times 4 is 16. 4 times negative square root of 5 is negative 4 square root of 5. Square root of 5 times 4 is plus 4 square root of 5. And square root of 5 times negative square root of 5 is negative 5. Because again, when you multiply a square root by itself, it just cancels the square root. And the minus 4 square root of 5 and plus 4 square root of 5 cancel to leave just 16 minus 5. So we can simplify that a bit more, and we have 12 minus 3 square root of 5 over 16 minus 5 is 11. And that's our answer. We can't simplify it anymore. If the denominator was something that could go in both 12 and 3, we could. But outside of that, 11 can't go into 3 or 12, so we have to just leave it like that. For the second one, we do the same thing. So in this case, it's 8 minus the square root of 3, so we're going to multiply by 8 plus the square root of 3 on top and bottom. So distributive property again, square root of 6 times 8 is 8 square root of 6, and square root of 6 times the square root of 3 is the square root of 18. And then over, and again we can just do difference of squares, so we're going to have 64 minus 3. So on the top, we have 8 square root of 6, and we do have to simplify the square root of 18 here. So what's a perfect square you can divide out of 18? 9. And the square root of 9 is 3. And what's 18 divided by 9? 2. So 3 square root of 2. So that's just a quick simplification of square root of 18 down to 3 square root of 2. And then 64 minus 3 is 61. And again, you can't simplify any of this anymore, so this is your answer. And for this last one, again, we're going to do the conjugate. So 6 plus square root of 7, we're going to multiply by 6 minus the square root of 7 on top and bottom. So on the top, we're going to have to, again, like we did when I was showing how the difference of squares works, we're going to have to multiply everything on the left by everything on the right. So 2 times 6 is 12. 2 times negative square root of 7 is negative 2 square root of 7. Square root of 5 times 6 is 6 square root of 5. And square root of 5 times negative square root of 7 is negative square root of 35. All over. Again, difference of squares. 6 times 6 is 36. And square root of 7 times square root of 7 is 7. And usually on top, it would be easy enough that we could just combine like terms. But there are no like terms to combine here on this one. So we're going to end up with the top staying exactly the same. And the bottom, 36 minus 7 is 29. And 29 can't go into anything on the top, so that is our final answer. Doesn't look very nice, but that's the answer. All right, and now time for the sponge activity. So 4 problems. I want you to simplify them. The top 2 are simplifying square roots with variables. The bottom 2 are rationalizing the denominator. I want you to multiply by the conjugate on the top and bottom. All right, that's it for this lesson. As per usual, please make sure to take notes in the entire lesson. Take a picture of everything, submit it all to Google Classroom, and have a good night.